All right, so we're going to wrap up optimization with this example here. So if you recall, on worksheet 7, the third problem on the back, we were asked to minimize the weight of the holding tank. And that's where some of us got stuck because we didn't actually know anything about the material that we were going to build this tank with. So typically we would say, well, we need to write an equation for the weight so that we can take its derivative and set it equal to 0. Well, unfortunately, we could not, in our homework, write an equation for weight because we didn't know anything about the weight of the material. So we said, well, let's just minimize the surface area of this tank, because if we minimize the amount of material we use, we would then be minimizing the overall weight. Now, I'm going to add to this. Let's say that now we have this same holding tank, and so I'm going to come over here and remind us it had a square base, open top, and it would hold 500 cubic feet. Well, actually I wrote that up here. So the same holding tank from our homework has a square base, so x by x, open top. We don't know the height. We can call it y, we can call it h, that's up to you. It needs to hold or have a volume of 500 cubic feet. Well, now I'm adding this to it. The base will use steel that weighs 2.3 pounds per square foot, while the sides will be built with maybe a thinner steel and it only weighs 1.2 pounds per square foot. What we would like to do now is to find the dimensions for this holding tank that will minimize the weight. Okay. All right, so if we want to minimize the weight, we need to write an equation for the weight. So I'm going to come over here and talk about that. Well, let's think about this for a moment. So this is the base of my tank. Here's my sides going up there. If we want to find the weight, we first need to know, well, how big is the base, right? So the base has an area of x by x, which is x squared, square feet. Okay. What we know is that the base steel weighs 2.3 pounds per square foot. So for every 0.3 pounds, I'm going to multiply my area by the weight. How many square feet do I have? And multiply that by the pounds or the weight per square foot. So I have 2.3 times x squared. That's going to be the weight of the base. Plus, now I have 4 sides. Remember, they're all the same. The side has an area of x times h, or x times y, whatever you're using. I'll use the letters that are in my picture. So I need to take how many square feet I have and multiply that by 1.2. So I have 4 sides, and each side has a weight of 1.2 times x times h. So the difference here from yesterday, or from that worksheet 7, is the addition of this number, and not addition as in we're adding, but the inclusion maybe of the weights. Okay. All right, so let's do a couple of things. So I'm going to multiply these together, but I'm also going to eliminate that variable, just as we did in worksheet 7. So if the volume equals 500 cubic feet, I'm going to come down here. Here we go. Okay. So the way we find the volume of a rectangular prism is length times width times height, or in our case, x times h. Again, these are all steps we would have taken on number 3. So we have a choice. We can solve for x or we can solve for h. Honestly, I'm going to prefer to solve for h because then I don't have to incorporate any square roots. So I'm going to take this and I'm going to go plug it in up here for h. So I now have the weight equals 2.3x squared plus, let's call that 4.8 times x, and then remember we're replacing h with 500 over x squared. All right, so let's simplify. Let's get rid of this x with one of these x's. So now I have weight equals 2.3x squared plus 4.8 times 500 over x. I could grab a calculator and multiply 4.8 by 500, but I'm just going to leave it alone for now. So we have successfully found an equation for the weight of this box. What we would like to do is to find the minimum. Now, key phrase, we're allowed to use a calculator, which you don't really need one, but it will be helpful. So here's the deal. If we have a calculator, we really should not be doing much calculus by hand. Here's the deal. If I have my equation for weight and I'm trying to find the minimum, couldn't I, option number 1, go graph that function called w, I'll call it w of x, go graph it, and then find the minimum. I mean, now we're taking all of the calculus out of it. As soon as I give you a graphing calculator, you don't actually need to use any calculus. Okay. I don't want to necessarily go find a minimum because, you know, it could be anywhere, and we don't necessarily want to spend 3 or 4 minutes just playing with a window like I did in our lesson this morning. May not have been 3 or 4 minutes, but, you know, it can be time consuming. So option number 2 is to use calculus, which is to, I'm not necessarily going to take the derivative by hand, but let's graph the derivative of that function and find the zeros. And honestly, we're going to have to graph a function either way. So I'm going to go with this method because when I go to find zeros, I know where zeros are. Now, I'll do it both ways, but I'm going to start with option number 2. Okay, I'm using an Inspire. Obviously, you can use an 84, no problem. Actually, I'll go ahead and use an 84. I think most people have been using those. All right, so here we go. I am going to go to my y equals, and I'm going to do math 8. I'm going to take the derivative of the weight, which is 2.3x squared, plus 4.8 times 500 over x. And then when x equals x, that's how we graph a derivative. And I just went to a standard viewing window, so I hit zoom 6, so that's going to go from negative 10 to 10 and then like negative 10 to 10. And now look, we're waiting, but that's okay. You see that little yellow thing spinning up there? That means it's doing its thing, so just be patient. While we're doing that, being patient, I'll remind those of us with, oh, there it comes. I will remind those of us with an Inspire how we do this. I'm going to add a graph page. And in my y equals, I'm going to go to my templates button to the right of the 9. I'm going to go to this box here that says dd blank of blank. So ddx, and then I'll type in my 2.3x squared plus 4.8 times 500 over x. We don't need to type anything else in. We don't need that x equals x. Oh, and look how much faster it graphed. So either way, we have our, I'm going to go back to the 84, doesn't matter. We have our derivative, and we're trying to find the 0. And what I love about this 0 is that it's going from a negative to a positive. So that's a very good indicator that we have a minimum. So find the 0 that goes from negative to positive because we're looking for a minimum. So second trace, I'm going to go down to number 2. It is somewhere between 0 and 10, so I'm just going to type those numbers in. And I get x equals 8.050. That's my critical point, which also is the minimum. We saw that, right? We don't need a sign chart here. Okay. Now, I have this. Let's go finish our answer. Because they didn't say find x. They said find the dimensions. Well, when we talk about the dimensions of this tank, it's blank by blank by blank, right? Length times width times height. Now, the good news is the x on our calculator is the same as this x here. So we have our 8.050. I just need to go find the height. How do we find the height? Oh my gosh, it's right here. The height equals 500 over x squared. Now, I'm going to be very careful because my x value has been rounded, right? So I either need to write down more decimals or I need to go store that x. I'm going to store it. So I'm going to quickly get out of here. I'm going to recall my x by hitting my x button, and then I'm going to store down here next to the 1. So I'm going to take x and store it for, and you pick any letter you want. I picked A, and I hit enter. So now I can do 500 divided by a squared, and now I know my answer is perfect. So 7.715. These are all in feet. Okay, there's my dimensions. Okay, I want to just quickly talk about option number 1. I'm sorry, I'm sliding all over the place. We said option number 1 is to graph the function and just find the minimum. So that's what I'm going to do next. So on this calculator, I'm going to add a new page, and I am going to go graph 2 plus 4.8 times 500 divided by x. Okay, oh geez, you can't see any of that, sorry. Okay, now I don't see it thinking, it's not spinning, so it's done graphing, and now it's just a matter of us figuring out where that is. The thing we need to keep in mind is our x's represented the dimension of the base, and our y represents the weight. So we know the x can't be negative, and we know that the y can't be negative, so at the very least, we can take these numbers and say, well, let's start at 0. Oh, I could have done that better. That's okay. Oh, goodness. Basically saying, let's just look in the third quadrant. Now, mine goes out to 10. Right now, it's only going up to almost 7. So maybe I change that to go up to, say, like 100. I don't know. Well, I still don't see a graph, so maybe I change it to go up to 500. Oh, okay, well, that's a good guess. So you see that graph coming down? That's what we want to find the minimum on. Maybe I'll go up a little bit higher. Maybe I'll go out a little bit wider to maybe 15. Okay, so here's my graph. I want to find the minimum. So however you use your calculator to find a minimum, click on the left side, click on the right side. Now, I'm going to delete this in red here. The thing with using this method, it seems the easiest, is that you have to interpret your answer because a minimum is an x and a y, right? So we got our answer. The minimum point is 8.05. I should go find more digits even though I know them. 8.050 and then 447.182. Those are the coordinates of the minimum. Well, remember, x is our dimension, so this is the side length of the base, and our y is our weight. Use the calculator to find the minimum. Make sure you understand what the x and the y coordinates are going to represent, especially if they said something like, what is the minimum weight? well, then we'd have it, right? So just kind of pay attention to that. So two great options if you have your calculator. Don't know, like I did, then this is probably not a great option. So I think we like this because we know where to find zeros.